All right, 1.2, fractional exponents and simplifying expressions. So a rational exponent. For any non-zero numbers a and b, a to the 1 over b is equal to the b root of a. In addition, if we introduce the letter c, we could say a to the c over b is equal to the b root of a to the c still, or we could write the c on the outside. So for what we're doing here, we're going to be converting from rational form, which is with a root, to exponential form, which is the exponent, right? This is rational, this is exponential. Rational can sometimes be called radical. I think that's what it says here. Radical, rational, it means the same thing. So let's look at this. Number one, for starters, on some of these, we're going to need to simplify them to where the variable is only written once using our exponent rules. For number one, we won't have, or for a, we won't have to do that. 4 to the 1 over 2. This is going to become a root, and the 2 will be our root. It'll be the number that our root takes. So it'll be the 2 root of 4, which that's just the square root, right? The square root's special. It doesn't have to have a number there. The square root of 4 is 2. B. For starters, we need to get those into a single variable. If this was x squared times x cubed, we'd add them up to make them an x to the fifth, right? If you're ever confused on exponent rules, make sure that you try it out in integers. That's what I always do, and it helps me a lot, right? If you're confused on what to do here, rewrite it as if they were just plain old integers and ask yourself, well, what would I do then? So here we added, so we're going to add again. So this will be x to the, and I'm just going to get my calculator out and I'm going to type in 2 over 3 plus 1 over 2, and that gave me 1 and 1/6. But we can't use mixed numbers. We need improper fractions. So this is 7/6, right? If you would prefer to do these by hand, I think that's great. I'm going to probably use a calculator a lot of the time. We need to write this in radical form. The 6 becomes our root, and the 7 stays in the exponent. So this will be the 6th root of x to the 7th. And because we need to simplify our root, right, we have 7 x's underneath the root, so we can take one out, right? Think about it like this. We have the 6th root of 1, 2, 3, 4, 5, 6, 7 x's. We have a group of 6 of them. Those can come outside. So this will turn into 1x on the outside because it came outside the root, then the 6th root, and then we had 1x left over. And there we are. That's as simple as that gets. C, x to the 1/2 to the 2/3. Well, this would be like x squared to the 3rd. And if we had it like that, it would be x to the 2 times 3. So that's what we're going to do here as well. We're going to multiply. So this will be x to the 1/2 times 2/3, which is x to the 1/3. The 3 becomes our root, so this will be the 3rd root of x, and then we had a 1 in our numerator, so it's just a plain old x, no exponent. That's it. For D, we have a numerator and denominator here. Let's think about what we would do if this was x cubed over x squared. Well, that would be equal to a plain old x, which is 3 minus 2. So this is going to be x to the 2 minus 1/2. 2 minus 1/2 is 1 1/2, which is 3/2. So x to the 3/2. So the 2 becomes our root, so this will be the square root of x cubed. We don't really have to write the square piece of it, the 2 piece of it. But now we need to pull stuff outside from our root. So we have an x cubed, and we need to pull things outside of that root. We have 3 x's in here. Let me write that in here. We have 1, 2, 3 x's. We have a pair of x's that corresponds with our 2 written there. And we can pull an x outside, and then we have a square root of x. Moving on. Number 2, write each expression in equivalent exponent form. So I'm going to take my root here, and I'm going to put it in the exponent. So that's going to be a to the 4 over 3, right? The exponent stays in the numerator, and the radical goes to the denominator. For b, we have a negative sitting out front. That's just going to stay there. We don't have to deal with that at all. This is a square root, so it'll be x to the 9 over 2. For c, there's a 2 right there. So we could say that this is like 1 over 3 to the 1/2. Then what do the directions say? It just says write each expression in equivalent exponent form. We could leave it as that, or we could leave it as 3 to the negative 1/2. I think I like that second one a little bit more because it's in the numerator. Lastly, part D. This is a square root, so it'll be x to the 4 over 2. 4 over 2 can simplify to be x squared. And there we are. All right. Oh, we have another page. Simplify each expression, write each variable in the numerator. So regardless of what number it is, it has to be in the numerator. X to the 0 is 1 to the 1 over 9 times x. 1 to the 1/9 is just going to be 1. So this will just be a plain old x. Here we have 2 variables, and they have their exponents, so we're going to add those. This will be 5 plus 1/5, which gives me 26/5. So this is x to the 26 over 5. And it did say to leave it an exponential, right? Yep. So we're just going to leave it like that. C, we're going to have x to the 10 over 5 all over x squared. Well, x to the 10 over 5 can reduce to x squared over x squared. Those can cancel, and they give us just a plain old 1. Part D. Starting off, our 5's can cancel. And then let's turn that root into an exponent. So we'll have xy squared over y to the 1/2. I'm going to take my 2 minus 1/2, so this will be x y to the 2 minus 1/2 is equal to 3/2, right? Yep, 3/2. Part E, starting off, this 4 needs to multiply in there. So this will be x to the 5/3 times x to the 4 times 1/2 is 2. Now I add those exponents, so I have 5/3 plus 2, which gives me 11/3. Part F. Well, this one's kind of a trick. We have a square root here, squared, so they're just going to go away. So this will be 1 over 5x. And what did it tell us to do? It said, write each variable in the numerator. Well, 5 is not a variable, so we're going to leave it where it is, but the x is. So this will be x to the negative 1 over 5. The negative 1 tells us that it flipped to the other side. And there we are. Make sure that you have this and that written somewhere, or keep this page handy. All right, good luck on the homework.